A bag contains 5 white and 3 black balls and another bag contains 3 white and 4 black balls. If one ball is drawn from each bag, what is the probability that one is white and the other is black? Now, according to the question, we are having the random experiment of drawing one ball from first bag and drawing one ball from second bag are both. Now, which type of events are these? Independent or dependent? Yes, it is independent. Are both independent events. Now, suppose this is one bag and this is the second bag. Now, first bag, second bag, two bags. Now, what are the conditions given? 5 white and 3 black balls. 5 white, 3 black balls, and in the second 3 white and 4 black balls. 3 white and 4 black balls. Okay. Now, let W1 and W2, W1 for white, W2 for white. Okay. W1 and W2 be the event of drawing white ball from bag 1 and bag 2 respectively. B1 and B2 be the event of drawing black ball, B for black, black ball from bag 1 and bag 2 respectively. Now, probabilities. Probability for W1, that is white ball, we are having 5 by 8. Probability for black ball, that is 3 by 8. Probability for white ball from second bag, 3 by 7. And probability for black ball from second bag, it is 4 by 7. Now, these are the probabilities. Okay. 5 upon total number of balls, 3 upon total number of balls. Okay. Similarly, in the bag 2. Now, required probability is equal to probability. Now, we are having, according to the question, It is W1 white ball and B2 or B1 W2. Okay. So now this becomes probability for W1 B2 plus probability for B1 W2. Now this is addition theorem. And the multiplication theorem is now probability of W1 times probability of black ball from the second bag plus probability of black ball from the first bag times probability of white ball from the second bag. Multiplication theorem. Now putting the values, five by 8 times B2 4 by 7 plus 3 by 8 times 3 by 7, 20 upon 56 plus 9 upon 56 is equal to 29 by 56. Hence, required probability is equal to 29 upon 56 answer.